Up to this point, life has only ever been found in our solar system on our planet Earth. However, we can't really know what lurks below in the liquid oceans that are ice covered on Mars and on one of Jupiter's moons, Ganymede. To better understand how much life can survive in these harsh locales, scientists have drilled into a subglacial lake that is in Antarctica that has been cut off from the rest of the world for thousands of years. This project was called Subglacial Antarctic Lakes Scientific Access, or SALSA for short. My Geosciences of Antarctica teacher, Dr. Harwood, originally introduced this subject to me, and he was one of the principal investigators for the SALSA project. He was there in Antarctica on December 26 when they bored into the subglacial lake, and he's been studying Antarctic research since 1983. He tells me that in addition to better understanding harsh ecosystems and how they survive, we also might gain information on the different advances and retreats of the Antarctic ice sheets that were caused by warming and cooling events of our world, and how conditions might change for our world if the warming trend that is occurring right now continues to proceed. However, this presentation will be exploring how all of this was made possible by a specialized drill called the hot water drill system that was created right here on the UNL campus, and how this drill utilizes a sterilization system to adhere to required environmental protocols. But first, we must understand exactly what a subglacial lake is. Dr. Harwood has told me that a subglacial lake is a liquid body of water located underneath the glacier that remains liquid due to the immense pressure above it from the ice. Antarctica has over 400 different subglacial lakes of varying sizes, and Lake Mercer, which was drilled into for the SALSA project, is one of the largest, and it is located 1,084 meters below the surface. That's over 3,500 feet below the surface. To drill to such an immense length, they used the hot water drill system. They couldn't use a regular drill because a regular drill could easily contaminate the ecosystem that they were drilling into, the subglacial ecosystem. This actually occurred on the first subglacial lake drilling project. There were samples taken that were contaminated by diesel fuel. So understandably, this is unfortunate because obviously we want more accurate samples that aren't contaminated, but more importantly, we needed to adhere to the environmental protocols of Antarctica, which are very important. The Antarctica Treaty of 1959 stated that no country may own or exploit the land of Antarctica. Because of this, special care is taken to ensure that any sort of scientific endeavor does not damage the ecosystem in any way or affect it, so that further research may be done inside the future. So in order to adhere to these specific protocols that were put in place by this treaty, the hot water drill system has a number of different processes that sterilizes both the equipment and the water that it uses. These were gone into great detail in 2 academic articles that were published in 2013 that were peer-reviewed and were linked to in the SALSA program website. So they are developing a hot water drill system for the Wizard project and a microbiologically clean strategy for access to the Williams Ice Stream subglacial environment. So this drill was originally used in the second drill project, which was the Wizard one, and was then again used in this Lake Mercer SALSA project. So the three stages that were performed to sterilize the water that would be used in the drill include filtration, irradiation, and pasteurization, and they are shown here in this diagram. This is a diagram for the Williams Lake, which was the second Wizard project, but essentially this diagram shows that the water in the hot water drill will come down through the drill be used to pressurize and melt the ice and then circulate back through these systems, which is the sanitation system. This demonstrates the first stage, which is filtration. There's two different filters here. It goes first through a 2 micrometer filter that will take out any sort of particulate contaminants that are bigger than 2 micrometers. And this one here, this filter, will take out any sort of particulate contaminants that are 0.2 micrometers or larger. The second stage is irradiation. This is 2 radiation systems right here that uses different types of radiation to kill microbial contaminants. Together, these kill most of microbials, and it's very dangerous for life in general. The third section here actually happens, pasteurization, is in the heater. Pasteurization is essentially when we heat the water to 90 degrees Celsius, killing off any more additional microbial activity, and also doubling to heat the water in order to bring it down into the hot water drill and melt the ice. So, this system was actually found to kill 99.9999% of microorganisms in the water and to sort out particulate matter. In addition to sanitizing the water, they also needed to sanitize the equipment that would be used and lowered into the borehole. This included disinfecting cables and hoses and other items. So this was done in 2 different procedures. The first one was to use a disinfectant solution of hydrogen peroxide that would decay into into oxygen and water. It would decay into those byproducts, making it extremely safe to use as a disinfectant solution. And the second measure was actually to use radiation again, because it's very effective to kill off microbial life. And this was used in a mechanism called the collar, and it would actually be located here at the top of the borehole, although it is not demonstrated in this diagram. This is the collar, and these 2 pictures are actually taken from the Developing a Hot Water Drill System for the Wizard project, and that is also where the past diagram was from as well. And this over here is actually a picture taken from a video that was posted to the SALSA website that was titled "A Glimpse of Mercer's Subglacial Lake SALSA Science Team." That was posted 2 weeks ago. Essentially, the equipment undergoes a bath essentially of radiation as it is lowered into the borehole. This is the borehole here, and as anything moves down into it, the radiation will be used to completely decontaminate it. This are the panels right here you can see that will produce radiation, but right now the flaps are actually open, and that would be quite dangerous if a worker was standing nearby. So it has a safety mechanism where it doesn't go on unless the flaps are closed. This is actually a picture looking from the borehole up into the collar. So this is actually a camera attached to this cable here, and we're looking up at the closed flaps right here. So it's very dangerous for life in general, which is why it's a very effective means to kill off microbial activity. It's so dangerous actually that Dr. Harwood told me, and it was verified in the articles that I read, that any sort of equipment that remains in the radiation will get completely destroyed. It'll just kind of erode it essentially. So it's got to be kept moving, or the radiation has to be turned off if the equipment is stationary. So, we've now explored the filtration, irradiation, and sterilization system that were used in the hot water drilling system, and we've explored why these measures are important to protect Lake Mercer ecology, and also just to protect the entirety of the Antarctic ecosystem. Now that you've learned about these different systems, you now have a further understanding of how technology is being advanced, integrated, and utilized to progress science while still respecting environmental stewardship guidelines, which are so important anywhere in the Earth, but also right there in Antarctica is being utilized. So thank you.